Assalamu alaikum. My name is Arusa Ishfaq and I am a student of MPhil Batch 6 at University of Management and Technology Sialkot campus. Today my topic of presentation is sensors and actuators. So basically here is an overview of sensors and actuators. Basically both are the devices and they are interlinked due to their functionality. Sensors are integrated in various electronic devices, means they are placed in different electronic devices for measuring or interpretation of physical data or any kind of stimuli. And sensors can respond to stimuli or inputs like light, motion, proximity, etc. And these all kind of stimuli then processed some kind of system that is linked to the sensor and generate an output. The output is generated in the form of electric signals like current, voltage, capacitance, and this is readable by the users. So basically we have seen that sensors are the devices that detect some kind of or respond to some kind of stimuli like light, motion, proximity, and then these kind of stimuli are converted into the electric signals which are the output of the sensors, and these electric signals then pass to the actuators. Basically these are also the devices, but what how they differ from the sensors. They receive the signal and then they perform some kind of mechanical action like the movement of the machine or any part of machine or turning off the switch, anything that result in the movement of mechanical portion. So basically sensors enhance the interaction of users with devices by collecting real-time data. Like sensors can collect data from the different stimuli, as I have mentioned earlier, the real-time data, and we can observe the valuable insights as well. And sensors and actuators change the energy domain. How the energy domain is changed? First of all, the stimuli energy domain is different. It can be light, it can be motion, can be pressure, but the output energy domain is different. That is in the form of voltage signal. And energy domains can be mechanical, electrical, magnetic, chemical, etc. So basically here I describe the link in the form of very simplified diagram. I can relate you guys with the functioning of sensors and actuators, that this is how the environment, there is a stimuli, there is some kind of signal from the environment that is sensed by the sensors incorporated into any kind of devices in our industries, in our equipments. So the signal that is received by the stimuli that is received by the sensor is then passed to the system signal, and this system then process that signals, convert these signals into the voltage and into the electric signals, and this electric signal is then passed to the actuators so that the actuators can perform some kind of action and to the environment. So this is how sensors and actuators are interlinked with the environment. So next is how sensors can make our industries more automotive or more digital, move to our industries towards more digitalization. So basically there is an overview that it can build automation. Like you can take an example of fire alarm clock, that if any kind of fire ignited in any portion of industry, so it is detected by the alarm detected by the fire alarm, and then it produces the sound energy and alarm, so the workers in the industry should get alert. So basically it result in automation. I mean to say that decision is taken automatically by the machine or the other equipments in the industry, and it help in predictive maintenance. It is a very broad terminology. Basically predictive maintenance is just like you can say it helps the machinery, it helps to detect any kind of failure in our machinery before the machinery is shut down or the industry is shut down and there is no period of production. So in order to avoid that downtime, sensors are incorporated into the industries and they help to predict the failures even before the failure can happen. So predictive maintenance technology also use sensors, and there is we can monitor our real time functioning and process automation. Processes are automated in industries, as I mentioned in the previous slide, that they are automation. The CN is all, any kind of signal, any kind of stimuli is sensed by the specific sensor, and then the actuators take the automatic decision and automatic functioning. So automation is introduced in the industry as well due to sensor technology. And future intelligent factories definitely will incorporate the sensors for better qualitative and quantitative material knowledge, and these are going to revolutionize the world, and the industry is going to become more automative by using this technology. And it is used in different fields like pharmaceuticals, chemical, and the globe is moving towards innovation and digitalization by using the sensor technology. Basically, and this is also an you can say the application of sensor technology, that it is used in robotics as well. And robotics use the sensor technology, and robots sense any kind of stimuli and then absorb their environmental surroundings, and then can take dynamic actions, just like actuators do, and take decisions like humans do. So sensors can monitor processing principles, and by using sensor technology we can make our surroundings, industries more secure and economically more well developed. How economically? Like it we have studied earlier that it reduce the downtime by doing predictive maintenance, so it also help in better economy of our industries and beneficial for strategies and products. So wireless sensor technology help the industries to prosper, to progress in a better way. And these basically sensors, as there is a word wireless. So wireless means the sensors are incorporated in the industries and linked online, linked through softwares or computers to the Internet of Things. And any expert which is in another country even can detect the signals, can in another location can detect the signals that is received by sensors, and can help in making decisions, and can do the real-time monitoring of the machinery, the just receiving the signals online by the wireless sensor technology. Okay, basically the next thing is the classification based on industrial applications. So basically there are a lot of sensors that can sense different type of stimulus, but there are few sensors that are most widely used in the industries, that are temperature, pressure, proximity, humidity. But we are going to discuss the first two. The one is temperature sensor and the second one is pressure sensor. So there is temperature sensor. Temperature sensor, basically as the name indicates, is just like sensor. In this case the temperature is sensed. The rise in temperature or the fluctuation in temperature is sensed by the sensor, wireless sensors, and it help in real-time observation, and this signal, the temperature which is sensed by the sensors, is converted into electric signals. So let's have a look at the paragraph. So basically in this we have seen that it detect temperature for real-time observation, and yes, ensure product safety and even workers safety and proper operation, monitoring human health as well. So for example, there is a very simple example given here, that in greenhouse gas effect, whenever we are make our better development of plants using greenhouse effect, so there are temperature sensors that are incorporated into greenhouses. These temperature sensors help us to real-time monitoring and precise farming, real-time monitoring of plant development, and help us to determine whether the temperature inside the greenhouse are sufficient for the plant development, or it is raised above the safe level, or it is not the required temperature for the proper development of a specific plant. So temperature sensors are used in greenhouses as well. The next thing is intelligent and portable. Portable means like they can be carried away along the patients. So these sensors, medical equipments also have sensors that measuring the human body temperature and provide 24/7 nursing to the patients. And car tanks also have temperature sensors to avoid the overheating, to avoid the downtime in the cars, to avoid their failure of the engines. And basically the last in the last lines, we will be discussed that what are the types of temperature sensors, or in what way temperature is sensed by the sensors. So basically there is basic two thermocouple type, p-n junction type, and thermal resistance and lead type. So basically the two explanation of the two are given in the coming slides. So the first one is thermocouple. So basically thermocouple is a very simple device. It helps to sense the temperature difference or temperature fluctuation in our given sample. So first of all, there is you guys can see that there is a metal A and a metal B. Metal A and metal B indicates that these two are different metals. They are not the similar ones. So these two metals are welded at one point and create a junction here. This is called the measuring junction or hot junction. Okay, this on the other hand, there is both ends of the different metals are also connected at the other end. This is called the cold junction or reference junction. Okay, they are not welding together here. So what is the exact functioning of the thermocouple is that whenever the temperature stimuli is received by the hot junction, the electrons excited with both of these metal, there is a conduction of heat with both of these wires. But as both of these metals are of different kind, have different conductivity, so there is a difference in the conduction of electron in the metal A. Speed of electrons to travel through the metal A and travel through the metal B is different. So there is a potential difference is created here, that is in the form of V output, and plus and minus, there is a potential difference is created, and this voltage difference, this potential difference is then measured out and is sent to the actuators to perform the mechanical action. So this is an equation. You guys can see that there is an equation where voltage is calculated by using that there is a constant A and the temperature of hot junction and temperature of cold junction, and voltage is calculated out here. This voltage, this electric signal is then sent to the actuator that perform the further functions. Function. And the next thing is the p-n junction. P-n junction is just like the there is a p-type semiconductor and there is a n-type semiconductor. So p-type semiconductor has more concentration of holes, or you can say a positive vacancies, and n junction has more concentration of electrons. So basically p-n junction mean there is a junction, there is a meeting point between these two regions where is an equal concentration of the electrons and the holes. So whenever the temperature or some kind of radiation or temperature is fall on that depletion region, this p-n junction is also called the depletion region, because it has an equal amount of holes and electrons. So whenever the temperature falls on that region, the electrons start moving, the holes start moving, and there is a movement of charges along the junction. And as you know that whenever the charges start moving, there is a voltage is created along these two ends. So voltage is, as a voltage is created, the voltage signal is sent to the actuator, which perform the mechanical function and help us in the automotive decision in the machinery, by automotive movement of the machinery or any kind of equipment in which sensors and actuators are implanted. Okay, the next type of sensors is pressure sensors. Pressure sensors, basically, as the name indicates, pressure sensors measure, or convert or sense the pressure input and produce a electric output, electric signals. And three type of pressure sensors are known, basically piezoresistive, capacitive, and piezoelectric. Basically all these, in all kind of these sensors, basically charges are created as a result of pressure, as a result of application of any kind of external force. So I am going to discuss the piezoelectric pressure sensors, how they are working. And basically piezoelectric pressure sensors, you guys can see, they are made from simple material, and have these sensors are made from materials that unite mechanical and electric forces. When pressure is applied or from the outside, material deforms due to the separation of positive and negative charges. Basically when we apply the mechanical force on that material, there is a separation of positive and negative charges within that material. So potential internal difference is created due to the placement of negative and positive charges on the opposite poles or opposite side of material, and this potential difference are determined to study the impact of external factors. Let's make it a bit clear by moving towards the next slide, this one. So you guys can see there is a basic diagram for the pressure sensor, where the pressure is applied on the sensor, and you guys can see there is a diaphragm at the end. When the pressure is applied, the diaphragm deforms a little bit, and this deformation put also force on the crystal, this quartz crystal, and as a result the positive and negative charges are separate out at the opposite poles of the crystals. I mean to say opposite side of the crystals. So you guys can see there is a positive layer or positive charges, the layer of positive charges on one side of the quartz crystal, and the negative layer of negative charges on the other side, and there is a potential difference is created at these two side of the crystal. That is measured, you guys can measure by using voltmeter as well, and this potential difference is then produce electricity, and this is then electric current is then sent to the electric signal is then sent to the actuator to perform the to carry out the further mechanical action. So basically there are some piezoelectric sensors and some name of the materials that have replaced the traditional piezoelectric materials like barium titanate, zinc oxide. They have replaced the traditional piezoelectric materials like ceramics and quartz. The summarization is just like that. The ceramics and quartz are used earlier are used in traditional pressure sensors, but nowadays zinc oxide and barium titanate are used. Okay, so the next slide is just like future perspective. What will be the future of the sensors? Or we can say that how the industry can be made more digitalized and can be made more automotive by using sensor technology. So sensors are basically linked intelligently with the associated devices to diagnose the problems in the system, diagnose any kind of leakage, any kind of excess amount of pressure than the desired pressure, or any excess heating of any machine. So with the help of sensors, operators can continuously, like operators can be humans as well, no? So basically operators can continuously collect data and can identify any kind of deformalities or anomalies, or you guys can say any kind of failure before it actually happen. So sensors minimize the downtime and increase productivity in our industries, and in future sensors will definitely play an important role in the better communication and towards more development and scanning capabilities. And the conclusion is just like country's economy definitely is accelerated because the industry economy is accelerated. Industry will become less vulnerable to the downtime and become less vulnerable to failures, and predictive maintenance can be obtained, can be help out the industries to predict any kind of failure before it just happens. So in this way, industry reforming in industry can be minimized, and economy of the industries increase as a result country's economy is accelerated, and industries can be developed and improved by using sensor technologies. Sensor technology is also important because they, provide data on different kind of stimuli. And all the manufacturers of sensors try to improve the sensors accuracy so that they can provide the accurate response, or they can can react to the accurate stimulus, and dependability and their efficiency as well. So we have the better technological development in the future. And there is a case study. Basically, we are familiar with the Apple's innovation, and Apple is using sensor technology in its application since decades. Basically, its camera system in iPhone is using depth sensing technology to unlock the phone and improve user identity. And there are basically, these are the two basic, also very important sensors: accelerometer and gyroscope. And both these measure the or detect, or you guys can say, can detect the stimulus of motion and screen rotation. Accelerometer and gyroscope measure the or produce response in to the motion and screen rotation. So it can detect the motion and can enhance the user experience. On the other hand, there is an option of auto brightness as well. The brightness of the screen is adjusted according to the surrounding environment, according to the brightness of the surroundings. So basically, in ambient lights, Apple has ambient light sensors that adjust the screen brightness automatically on the basis of surrounding light intensity. Thus it optimize the visibility and save battery life. If basically there is a proper procedure behind this sensor, that if for example in daytime, there is if you have your phone, and in daytime, auto brightness option will have the more brighter screen of your mobile phone, but in night time or in dark, the auto brightness option will minimize or will dull the screen of your phone. This is because in daytime, more number of photons of sunlight fall on your phone screen and create, and more stimulus from the sun rays are falling on your mobile phone. But in night time, there is no sun, and there is no kind of radiations falling on your mobile screen, so stimulus decreases. As a result, the screen of your phone also become dull. It has also produced less response. Okay, the next thing is barometer in Apple. Also, barometer measure the pressure, atmospheric pressure in the atmospheric pressure around in our surroundings is measured by barometer in Apple phone, and this helps in weather forecasting. This will tell us what will be the weather conditions in our nearby regions, in our nearby environment. And this is the last topic of our presentation, that is sensors and actuators contribution towards SDGs, sustainable development goals. So as I have discussed earlier, that there are a lot of variety of sensors that are available in the market. So there are sensors that can track greenhouse gas emissions, that can track carbon dioxide emissions, that can track the greenhouse gases. And as a result, when it's track the greenhouse gases, actuators produce a response. As I have said earlier, they can manage industrial processes to reduce the emissions, to reduce these green gas emissions, and regulate the irrigation systems, and regulate the emission of the harmful gases. And this can also irrigation systems regulated by the actuators, and we can conserve water as well. And these all actions can contribute to the climate action, towards the conservation of our climate. And the next SDG is 6, which is clean water and sanitation, also achieved by using sensors that are implanted in the water plants, can monitors the water quality and can detect the leak of water at any point. And actuators can regulate the water flow, and treatment processes are managed as well by the actuators. So the SDG 6 is also achieved by using the sensors. And there is a SDG 3, which is good health and well-being. And as we have discussed earlier, sensors are used in pharmaceutical industries, in hospitals, in medical equipments and devices. So basically these all can contribute towards the better well-being of a human being, and actuators are implied in the drug delivery systems. So this is all about my presentation. Thank you.